This is Ram. I'm from OpenLedger. I'm one of the core contributors here. I know that there's a lot of panels, but just try to hear me out for next 10-15 minutes. I think you will like this. So OpenLedger is a blockchain network for AI. We enable people to build specialized AI models, and we want to make sure that every stakeholder who's in the process of enabling these models get benefited. We are layer 2 focused for AI, and today I'm going to talk about why the future of AI is specialist. So if you take a look at over the years, we've always been seeing that there are 3 major components of AI, right? One is compute. I don't think it has come out really well, but you can see there. As you can see over there, that there is compute, data, and models. And most of the time, if you take a look at on the compute side, like how it happened in the traditional space, NVIDIA pretty much solved the compute problem. That's one of the reasons why OpenAI was actually there. OpenAI happened because NVIDIA could actually solve the compute problem, and there was enough data for them to use and build better AI models. But what really happened on the agent side? If you take a look at the models that enable agents to happen, most of the agents were just a ChatGPT wrapper, right? They did not have any particular use case because they were just using OpenAI as a backend, and they built a ChatGPT wrapper on top of that. But what kind of made these agents to become better is the data and the models that were provided for them. People made better models so that these apps could be much better and not just a ChatGPT wrapper, which just gives you similar answers to OpenAI, right? That's going to happen to Web3 as well. If you take a look at the Web3 space, we initially solved the compute problem. There were players like Jensen, IONET, Aether, and all these guys who have been trying to solve this over the last 3 years. And we pretty much solved the compute issue that is there. We have enough compute right now. What people are looking at again right now is to see how we can have more abundance of data sets and more abundance of models. So the apps that can be built on top of this, or agents that can be built using this, can be much better than what they are today, right? And OpenLedger is trying to solve the problem between data and model side. How can we enable better data sets and better models can be provided for these agents to be much better than what they are today? And if you take a look at it, right, the future of AI is going to be much more specialized than what we see today. Most of the apps that we see today, which run behind an application logic, will be replaced by models. A good example of that is Perplexity. If you take a look at it, they replaced Google search engine, which was a logic where it basically scraped the entire internet and gave you data sets, it gave you websites to look at if you search around a topic. But Perplexity changed that. It took the same data set, it took the same searching on the web, and it actually gave you better output by using a model behind that. That is the future of how apps will change. Let's take a look at a fitness app, right? If you see a fitness app today, again, it has a lot of application logic, but that will be changed by models. You would probably use a fitness app to seek the model for, let's say, fitness. You would also use its model around sleep to understand how your sleep data works and stuff like that. So apps would start changing, right? When apps start changing, you need better models. You need better specialized model than generic models out there. And you need models which are hyper-focused to a particular category. How apps are hyper-focused to a particular category, you need models behind that power these apps as well. And if you take a look at it, how human thinks and these apps and agents things are very similar. Us humans, we rely on a stimuli, we feed that to our brain, and we provide that with a signal. That signal enables various actions to happen. And if you take a look at an agent or an app, it is very similar. You give an input, it runs it through its brain, which is an LLM. It uses a RAG, and then it basically gives a stimuli for the output to come. And it uses various apps out there to actually give you an output. But for all of these, as I told you about, most of the models that they use behind is a larger language model, which is very generic. It is trained on internet data. It's very broad, but not depth, right? And humans are much different as well. Usually humans, we are generalized, where we study till undergrad, then we specialize in a particular subject, and we always go to the specialist. If we have a problem, we want a next surgery to be solved, you go to the surgeon, you don't go to a general medical practitioner. Very similarly, in apps and agents, we want to use something which is specialized, which is not generalized. We want to use an app which is much more precise than the current models today. So what can happen? How we can enable this? You want to enable better models to be there. You want to enable a platform that encourages people to build better models. That's what OpenLedger does. We enable people to build models at scale. There are currently many specialized models that are being built across. We have models in healthcare, we have models in finance. These models have outperformed how ChatGPT is, right? For example, Bloomberg GPT is a finance model which is much better performing than any open source Llama model out there or ChatGPT out there, right? And what we do is that we provide a platform that enables data contributors to come forward, come together, collaborate with data, and build specialized models. And once they've done, there's an important piece to it, right? People who have been part of the network, people who have been contributing to these models to be built, have to be rewarded for that. That is where we use data attribution to reward the data contributors for the data that they provide. So we are a layer 2 that enables people to contribute data sets, build specialized models with that, and then use data attribution to reward back to the data contributors. There are 5 major components to our platform. It starts with data, and then the processing of that data, the model development, and then the reward that goes back to it. The first piece is the model proposal. Anyone who's looking to build a specialized model proposes that on top of OpenLedger, where they seek what kind of data needs to be collected, and they showcase that, and they enable people to contribute data sets to these models. And once the data sets are being contributed by people, they can go ahead and take a look at the models that are there, the models that are proposed, and what kind of data they need. Now, users can go ahead and contribute these data sets, which are basically like questionnaires or documentations of code that you can go and contribute. And as this is being collected, it's like a data repository. The model developer tries to figure out what kind of data is being collected, and he decides when it needs to be converted as a model. And after this, they go ahead and use our model factory platform, which is a no-code platform that enables the model builders to use the data that they've collected to fine-tune and build their own specialized model. This is a no-code platform that enables LoRa fine-tuning, where you can choose any base model. It could be an open source model like Llama or DeepSeek or Mistral or whatever it is, right? You can use our model to go ahead and fine-tune data sets and build your own specialized version of your own model. And once the model is ready, once you have a specialized model, you want to make sure the deployment is efficient, right? All these model developers are bootstrapping. They don't have much cost to spend for compute and stuff like that. So they would want to use a platform that can enable them to have deployment much cheaper, right? That's where OpenLoRa comes in. It's a framework that we've announced where users can go ahead and deploy multiple specialized model in one single GPU. If you take a look at the typical case, a model is always allocated to one single GPU because you need to have enough space so that the inference can happen. You can have one model running on one GPU. But what we've done is that we want to make sure that we can have at least 100 specialized models deployed in one single GPU. So we've made sure that the model deployment itself is modularized. So what really happens here, right? You fine-tune a model, you have a specialized model. All of these models run on one single base model, one single larger language model. So we enable people to first deploy the larger language model, which could be DeepSeek, Mistral, or Llama, and then go ahead and deploy the fine-tuned layers separately. So each fine-tuned layer of the specialized model is an adapter on top of OpenLoRa. So every time there's an inference comes in, every time someone asks a question to the model gets to choose which base model it goes for and then choose the fine-tuned layer that has to be used to give the answer. So basically what we've done is we've broken down the base model and the fine-tuned layer so many specialized models can deploy in one single GPU. That's OpenLoRa, where people start deploying models on top of this. The last piece is the most interesting piece here. Data has been collected, model has been built, model is deployed. Now you want to enable every stakeholder in the process to be benefited, right? As this model gets launched, as users go ahead and start using this model and they pay for this model, the revenue is split between the model developer and the data contributor. And how we do that is to make sure that every time a model throws out an inference, on that inference we figure out which data caused that inference to happen. That's how we attribute back to the data contributor. It's called proof of attribution. We enable people to contribute data sets, and when their data is being used in a model, On every inference, we figure out which data caused that inference to happen, and we enable our layer 2 to use to reward back to the data contributor. And that happens to our attribution layer. So every time a model gets used, you can go and check whether your data was causing that inference to happen, was causing that output to happen, and then you can basically see it on chain on how much you're getting paid out of the inference that was paid for. That's the last piece of our platform. We have many folks building various use cases on top of us. These are some of the examples. I will just walk you through a couple of 4 examples which we're very happy about. One of them is called Data Intelligence Layer. It's built by an ex-Google DeepMind team. The founder name is Krishna Srinivasan. He's building a verticalized internet model. Think of this to be a data availability layer that will enable other models to be built. The models that are being built on our platform need a lot of verticalized internet data, so they will be using this model to build their own models as well. And then we have a model that's being built for DeFi. This is by a team which has experience in DeFi about last 5 years. They're building this model to enable better DeFi agents. Now, these agents cannot be completely autonomous, right? I think there is a lot of time for that, but the DeFi agents can provide better suggestions, and for that you need a better model. So this is a DeFi model that's been trained specifically on on-chain data and off-chain sentiments. And then we have a deepened model that's currently being built. This is by a team named Ambius Network, which have a lot of weather data, and they're building a model that can enable this weather-based application to use as well. This cannot be run on a larger language model because the larger language model simply does not have the data set. So they built a specialized model especially for this particular purpose. And the last one is a Solidity model. We've been speaking about this for a very long time. It's coming out soon. This model is predominantly trained on Solidity data sets, code and code descriptions, and documentations regarding Solidity, which can enable Solidity copilots to be much better. If you take a look at Cursor as a model, it understands top 30 programming language, but doesn't understand Solidity, right? It's not an expert in Solidity. So we want to enable this model to be one of the best models out there that can power copilots, audit agents, and so on and so. These are some of the models that are being built on top of OpenLedger. I would like to end my conversation with this one particular slide. We have built a purpose-built layer 2 that can enable each and every section that I explained about, the data contribution to be on-chain, the model development to be on-chain, and then the attribution where we attribute back to the data contributor to be on-chain as well. It's a purpose-built layer 2 for enabling AI models to be built and rewarding the data contributors and every other stakeholder that is being part of the process to get rewarded as well. And I would like to end this by saying that we are building the YouTube movement for AI. I was actually talking to someone about this, right? If you take a look at it, pre-monetization, YouTube had very bad content. The content was not useful at all. That's how Hugging Face and other platforms it's today. The models and the data sets that are being currently built are not so useful because they don't get monetized. We want to bring in the YouTube movement for AI. We want to enable monetization of AI. How can we enable users to contribute data sets and get rewarded for that was the question. That's how OpenLedger was born. We want to make sure that everyone who is in the process, who contribute data or build models or enable the model to be much more efficient, get rewarded as part of the process. And thanks a lot for this. I hope someone listened here. Thanks a lot for that. And we are backed by some of the prominent investors and angels in the ecosystem. We are currently in testnet and going mainnet soon. And if you have any questions, I'm around, happy to answer as well. Thanks a lot, guys. Thank you.